Oh, hi kids. Mr. Lee again. Still in my backyard going for a spin. We're back with a packet breakdown for the third time. Let's get started. No more time to rhyme. But if you stay watching to the end, maybe you'll see me spit a little fire then. And if you're like, what are you even talking about? Don't worry about it. Just stay watching and don't tune out. So go ahead, get your packet, get a pencil and a pen. And when I say go, the number race will begin. But one other thing before we start. I almost forgot this part. In case you were wondering, yes, in fact, I do have the horses in the back. Okay, here we go.
On your mark, get set, go. I know you didn't beat me that time. All right, this week, the topic we're talking about is force, motion, and energy. So hopefully you've been viewing the previous two videos. If not, just a quick breakdown of what we're doing here. I'm just quickly working through some of the material in the packet, hitting some highlights. I'm not trying to cover everything, and then walking through just a couple questions to help get you started for your weekly science packet. All right, motion. Zoom in a little bit so you can see it real good. And this is all stuff that we've covered in class. Hopefully you remember it. If not, I'll remind you of a few things, and then as you read through it, you can be prepared to answer the questions. Motion is the process of an object changing place or position. That's the key part right there. So if something has motion, that means it's moving. So it changes the place where it's located and the position. If you see an object moving, it's going from one place to another to change the positions. Speed refers to the rate an object changes position. So basically how fast or how slow. When you're in motion, you might speed up. So again, if this is your first time checking out a video, I've got this little handy gadget to point stuff out. When you're in motion, you might speed up, go the same speed, or slow down, but you're moving, all right? If you're speeding up, that's accelerating. Accelerate means you go faster. The gas pedal on the car is the accelerator. You press it down, it makes you go faster. Decelerate, basically the opposite of accelerate, means you slow down. So you can think about like the speed decreases. DEC, the beginning of how you would spell decrease to make it less. That means you slow down. All right, force. A force is a push or a pull. Push or a pull, two types of forces. Some forces affect only objects that come in physical contact with one another, while other forces act at a distance and affect objects without contact. So, for instance, a magnetic force. You can make something move or apply a force to it with a magnet without actually touching it. You get it close enough, it's a strong enough magnet, then you can move it. All right, forces, or pushing and pulling, can change the position and the motion of an object. So when you apply force, you can make the object move and you can change its position. All right, these are some types of forces. Again, this is all stuff we discussed in class, so hopefully it's familiar. Friction is a force that works against an object that is moving along a surface. It can slow it down or it can stop the object. So we did an experiment in class before where I had a little clipboard propped up to make it like a ramp, and we had a little toy car. At first we just let it slip down the clipboard with nothing to interfere with it, and it rolled pretty far. And then we repeated the process and put some sandpaper, and it made it slow down. And then it had some rougher sandpaper, and it slowed it down even quicker because there was more force of friction dragging against the wheels. Gravity is an attracting force that tries to pull two or more objects together. So when you think gravity, you probably think about the planet Earth, or really any planet, any large body. There's a force of gravity that's causing you, whatever you're doing right now, sitting on a couch, standing up, however you are positioned right now, you're not floating around because the force of gravity is pulling you down toward the center of the Earth. Gravity depends on two things: the mass of the objects and the distance between them. All right, inertia. We've also talked about this as a vocabulary word we've covered in class, is a property of matter referring to the way an object remains at rest and doesn't move unless someone or something forces it to move. So if you just leave it completely alone, it'll kind of stay how it is. But when you act upon it with a force, then it could move. And then work is the ability of an object, or the ability to move an object. An object must move in order for work to have been done. So just think about, somebody that's working at a job. Maybe they got a responsibility to move big, heavy containers or objects. The stuff, if they're doing their work, they're going to make the things move. That's not like scientifically what it means, but that's kind of a little way to think about in your mind to remember. All right, and then we're going to not go through this in detail, but there's some simple machines right here. Different types of simple machines, and it's got a little breakdown of how they help to make the work easier. This isn't required, but if you want to have a little homework assignment, you could Google Magic School Bus. And I know there's an episode from even the original old school Magic School Bus, not the new one on Netflix, that is about simple machines. But if you have Netflix and you want to check out Magic School Bus Rides Again, like the reboot, they also have an updated episode about simple machines. You can do some extra homework that way. All right, last topic right here is energy, is the ability to do work. So and again, we're not going to go over this part in detail either. This is stuff you've covered previously, kinetic and potential energy. I know this is a topic that was covered in 4th grade. You guys came into 5th grade already knowing plenty about this, so I know you've previously been taught it. And there's also other types of energy listed here. So even though I'm not breaking this down right now in the video, you still need to read through this and kind of on your own, mark it up, make sure you understand it, and refer back to it during your questions. Okay, so if you scroll down or flip over to question page number 5, we're just going to hit a couple questions to kind of get you started working through the packet. All right, on page 5, question number 7. Zoom in so we can see it real good. Pushing and pulling an object can change the blank of an object. All right, so to see how you can think through this, my answer options, it doesn't say anything about force, but I know that the topic it's talking about is force because it's involving pushing and pulling. So to be able to understand the question, get it correct, I'm going to go back and look at this section of my notes discussing force. So pushing and pulling an object can change the blank of an object. So let's go back to our section on force at the very start. A force is a push or a pull upon an object. In this very last sentence that we discussed, forces, pushing and pulling, can change the position and the motion of an object. So that right there is what this question is discussing. It can change the position and the motion. So page 5, number 7, I know that it can change the position and motion. The answer is C. Page 6, let's look at number 8. A gear, this thing here, is made of 2 wheels that have the notches that fit together, either directly or by a chain or a belt. So these right here are gears. You've seen those. There's one particular thing that you've probably seen them on that would give a good clue to the answer to the question. The belt allows one wheel to turn the other wheel. Which of these would move with the help of gears? So you have 4 different types of items right here. Which one of these things is something that would move with gears? So again, let's scroll back up to the notes. This is the section we skipped over with the simple machines, but you can see right here they got the same image to help you locate the section of the notes. It's discussing what a gear is, and even without having any sort of understanding of what the notes are discussing, I'm pretty confident y'all could get this correct just from what you know about things in life. Which one of these would move with the help of gears? A soccer ball? No, there's no gears in a soccer ball. You just blow it up in the air. A bicycle? Oh yeah, probably a bicycle. I'm gonna put a little, I think it's probably bicycles. Look at the other ones though. A flag up a flagpole. No, that's different. That's something where you got a handle and you crank it and it kind of winds the string or the rope up to make the flag go. It's actually a pulley, so it's not that. And a rocking chair. No, it's just got like some rounded feet on the bottom to make it sway back and forth, so I definitely know it's a bicycle. So a bicycle has gears. And next one we're going to go over together, the last one, page 7, look at number 8 also. A, so this right here, whenever it has a or an, that means what belongs in the blank. It might start with a consonant or it might start with a vowel. Because if it starts with a vowel, then technically it should be an. So anytime you see that right there, that means they're not giving you any clues about the answer just based on the first letter. So that's all that means. A or an blank is a material that does not allow very much heat to run through it. Okay, so again, I didn't discuss this part in the little teaching segment, but we can look at our notes and refer back. So if it does not allow much heat to pass through it, then I'm going to go back to my notes and see a section that's discussing things related to heat. Okay, so I know it's, well, thermal energy. Thermal energy basically is related to heat, like the thermostat in your house will will adjust the temperature. If you need to have your temperature taken, you'll have a thermometer. So you can see the root word therm relates to heat. But actually, it's very, very last part of the notes here is what we need to be looking at. Conduction is the transfer of heat energy from one object to another. So if it's a conductor, it's a material, whatever it might be, that allows heat to run through it. So the heat very easily passes through the material. An insulator is a material that doesn't allow very much heat to run through it. So if you look at the picture, we're showing a pot on the stove and it's pretty hot and you're getting ready to go grab it. You want your oven mitt to be made of a material that's going to stop the heat from coming through to get to your hand. You don't want to have like a metal oven mitt. That'd be silly. All right, so if it does not allow very much heat to run through it, let's go back up and look at what we just read. It doesn't or does not allow very much heat to go through it. That's an insulator. So page 7, number 8, that is an insulator. All right, and again, these are very similar to the previous week's science sections. You have a lot of multiple choice questions, and toward the end, you have a word bank and some fill in the blanks vocab. So again, as you read back through it, you take a couple notes, you underline things, carefully read the text, and then go back. You shouldn't have any problem completing your packet.
Man, all that teaching sure does make me hungry. Let's see what we got for lunch. Oh yeah. Hey, why you hating on my lunchbox? 'Tis the season. Indeed, he's risen. Season, risen. Probably not the best rhyme. Anyway, let's see what we got for lunchtime. Oh yeah, you know we gotta have this. Protein shake. Hold on, this will take me like 0.2 seconds. That's good stuff right there. Oh, what else we got? Now, I really probably shouldn't eat dessert before my meal, but this is Mrs. Lee's cake. Who can resist it, you know? Again, carrot cake. 'Tis the season. Bunnies, eat carrots, Easter bunny. All right, anyway, let's see what we got here. Oh, I'm gonna save that for later. I poured my beer right there. That was on purpose, okay. All right, anyway, let's see what we really got to eat. I'm looking for one of those big fat sandwiches that I like to eat every day. Thought I remember packing that. Seriously? Takis? I don't even eat Takis. What was I thinking when I packed my lunch? All right, here you go, horsey in the back. All right, let's see, where is that big, oh, here's that big fat sandwich I was looking forward to. Oh yeah, that's good. What? You got Takis everywhere. Where did those even come from? Oh, never mind. Hey, horsey, did you like those Takis? Yeah, you did? You shaking your head yes? Alright, well, sure hope you're hungry. Because we got Takis on Takis on Takis on Takis on Takis on Takis, so many Takis. I guess if my horsey in the back likes them so much, let me go ahead and give these things a try. So tiny, it's not like it could really be that hot. Oh man.
Oh, hi kids. You liked my video, didn't you? You like that delicious looking cake there, don't you? Well, anyway, until next time, stay safe and stay healthy. And as always, don't forget to like and subscribe.